Okay, so this is our first major unit in chemistry class. It's dealing with matter. Okay, so in this unit, we can break it down into three lectures you can say that we're going to be doing. First one's going to be talking about chemical and physical properties of matter and defining matter. The next one's going to be talking about how do we classify matter due to its state and composition. And then the third video, we're going to talk about like particles that make up matter and the factors that influence those particles. So in saying all that, let's talk about our first section today. What is matter and the physical and chemical properties that influence them? So if I'm going to sum up what we're going to do today, our objective is to be able to observe a phenomenon or observe an action and determine if it is a chemical or physical property or a chemical or physical change. In saying that, let's dive into our lesson and see what we can learn. So I guess the first topic that we need to talk about is what exactly is matter? Matter is anything that occupies space or has mass. So we can say that matter is defined as anything basically, whether it's the chair I'm sitting in, my shirt, the desk, the computer in which I'm recording this off of, the iPad or digital device you're viewing this off of. All that can be classified as matter because it, one, takes up space and two, has mass. Okay? If we are referring to a specific type of matter in chemistry, we like to throw a lot of terms out at you. We like to throw a lot of terminology at you. If we are talking about a specific type of matter, we usually want to refer to that as a substance. So if we don't want to say, hey, the black shirt that Luke is wearing, every time we want to talk about that, we can just say, hey, that's substance. Substance A, or we want to say unknown. Unknown substance B. Anyway, when we're going to be vague in chemistry and we really don't want to say like, hey, a specific thing, but we just want to say this substance is undergoing something, or this piece of matter is undergoing something, we just say substance, whatever. So matter, anything that has mass or takes up space, so basically anything, and matter can be considered a substance. Now that we determine what matter is, basically everything we deal with, we need to understand that change does happen in matter. I mean, matter doesn't just sit there. It doesn't just remain the same all the time. There's stuff interacting with everything in our environment. For instance, we put ice in our drink to make it colder. That ice is going to melt. It's going to interact with it. Okay? So there's different types of changes that happen. The first one we're going to talk about is physical change. Physical changes only alter a state's appearance. It does not change the chemical makeup of that substance. So in other words, we still result in the same substance being formed. Nothing new is made up. Okay, so the atoms or molecule that we start with are what we are going to end with. Nothing changes. So for instance, let's think about this. If I have a pot of water, okay, I put that on the heat. I put it on the stove. I'm boiling water, okay. I have water. As it heats up, first this water is in liquid form. Okay, so we have liquid water in my little pot or my glass, whatever we want to say. As it starts to heat up, that liquid water starts to bubble. Well, what are those bubbles? They're still H2O molecules or water molecules, but they are turning from a liquid form to a gas form. That is a physical change. We started with water in a liquid form, and even though it looked really different at the end in the gas form, it still was H2O. It didn't change. So, in saying that, a physical change can make something look different, but it does not change the chemical makeup of it. On the opposite end of the spectrum, we have chemical changes. Chemical changes result in a new substance being made. It cannot be undone. So when a chemical change occurs, atoms, they come in there, they kind of change up what's going on with the molecular makeup of this substance. Once that happens, it can't be reversed. That's when we say a chemical change occurs. An example of this would be rust of a nail. So we put an iron nail outside. Okay, that nail reacts with oxygen in the air, and it forms what we call iron oxide or rust. The longer we leave it out in the air, the more it interacts with the elements, the more it rusts. Though we can put some lime away or some kind of chemical that gets rid of rust, that rust still has reacted with that iron. And though we might get rid of some of that rust, we will never have the same amount of iron before the reaction as we did after the reaction. So we've talked about chemical and physical changes. Well, we need to talk about properties. Physical and chemical properties are indicators that physical and chemical changes happened. That's the biggest way you can think of these as. How can I tell that a chemical change happened? Well, I had a chemical property that I could observe. These properties are just basically observable phenomenon, and those are indicators that, hey, something happened here, whether that be a chemical or physical change. So physical properties, these are properties a substance can display without changing its composition. So for instance, if I smell something, okay, just because something stinks does not mean that it is changing its chemical makeup. Same thing with taste, so odor, taste. Then we have color, density. We haven't really learned much about density yet. Just take my word for it. Okay? And then melting point and boiling point. So those 6. If you see, smell, taste, or observe one of these phenomenons, a change in one of these phenomenons, that might be an indicator that a physical change is occurring. For instance, you're at the gas station and you fill up your car with gas and you smell this gaseous fume. Okay, the smell of diesel, smell of gasoline, whatever it is. This is just your liquid gas, okay, reacting with the air, turning into gaseous gasoline. Okay, that's how we smell it, physical change. Okay, it changed its appearance, but it didn't change what it is made up of. So smell, that's a good example of one. Then we have chemical changes, okay, or chemical properties. So chemical properties are properties a substance displays only whenever its chemical makeup is changed. Okay, remember, chemical changes cannot go back. They can only go one way. So a chemical property is shown when this change occurs. Some examples of this is corrosiveness, so can it be broken down? Acidity, so when an acid takes something, it can dissolve it, and we'll get into acids later in the year. Toxicity, so is it toxic? And then flammability, once I burn something, I'm not going to get that thing back. Okay, so an example of this, and easy, sticking with our gasoline, if we're at the gas station and some horrible thing happens and our gas pump catches on fire, that gasoline in there is going to just ignite. And this big fire that we see is the burning of that gasoline. So flammability, or something catching on fire, is a chemical property that indicates a chemical change that occurred. So to sum up what we have matter. Okay, it can go through chemical changes or physical changes. Okay, those changes are indicated by different properties through either chemical or physical properties. So remember, a property shows that a change occurred. The difference between a chemical change and a physical change is chemicals can't be undone. Chemical changes cannot be undone. While physical changes can always be reversed. Now let's work some problems just so we can see where we're at and see that you can get some of this. We're going to identify the phenomenons we observe here, or that are stated, and we're going to determine whether they are chemical or physical changes. So our first example is burning wood. Okay, so what did I just say? If we burn anything, we can't go back. So that must mean if I do burn wood, then that's going to be a chemical change. Then, next one is crushing a can. Okay, if I take a can of Coke and I just crush it, okay, did I change its chemical makeup? No, it's still a can. Okay, we didn't change anything in it. It may look differently, but it's still physically a can. So that's going to be a physical change. Then we have breaking glass. So I have a cup and I drop my cup. Okay, when I drop that cup, even though it may shatter, the glass may break and shatter, it still doesn't change the fact that, hey, I still have glass there. It may be in a million different pieces, but it physically just changed how it looked. It didn't chemically change its makeup. So that is going to be a physical change. Then we go to the souring of milk. Okay, so if milk goes bad, it kind of curdles and makes this nasty layer on the top and liquid on bottom, and it smells horrible. Okay, but we see that we have our milk and it's soured and it's gone bad. Think about this. Even though we smell something really nasty, okay, let's think about, can we make this milk right again? Can we make it where it's unsoured? The answer to that is no. So because we cannot undo this reaction, this is a chemical change. Fifth one we're going to talk about is cooking an egg. Okay, you get a fry pan, you break your egg open in it. It starts turning from this clear translucent liquid around the yolk to a white area and then the yellow yolk. Okay, same concept as our milk. Can we get that white area to turn translucent again? No. Because it can't be reversed, that means that is a chemical change. Okay, melting an ice cube. We've talked about this earlier in the unit. If I have a piece of ice, okay, it's made up of water, H2O. I melt that. It turns from a solid to a liquid. Okay, that still does not change the fact that it is still water. So because it doesn't change the chemical makeup, that's going to be a physical change. So right now we have burning wood is a chemical change. Crushing a can, physical change. Breaking glass, physical change. Souring milk, chemical change. Cooking an egg, chemical change. Melting ice, physical change. Chopping wood. Okay, let's think about this. If we're chopping a tree down, okay, we're chopping some wood, okay, do we change the chemical makeup of that tree? No. Okay, we might alter its appearance. It might be from standing up vertically to being on the ground, or it might look significantly smaller, but it is still made up of wood. So that's going to be a physical change. And then finally, baking cake. Okay, we have our cake batter in there, and though that cake batter may be delicious, we have to cook it up. Okay, so you put that cake batter in a pan. That pan goes into the oven. When it comes out, it is no longer a liquid, but a solid. Okay, no big deal. It changed its state. So we're immediately thinking physical change, right? Wrong. Because when we have our cake, can we get that back to a batter? No. So this cake, because even though it changed from a liquid to a solid, it cannot change itself back. So that must mean it has to go through a chemical change. So now we're going to talk about are we observing a chemical or physical property? So we did a whole bunch on chemical changes. Now let's talk about chemical physical properties and some practice problems with them. So the first thing is the blue coloring of a sapphire. Okay, so a sapphire's blue. Coloring, something that's colored, that's going to be a physical property that we're observing. Okay, remember, physical properties are color, taste, density, smell, etc. Okay, the next one, testing whether a substance is flame retardant or not. So basically testing whether a substance can be caught on fire. Okay, by now you should get the hint that anything that catches on fire is not going to go back. That's going to make a chemical property. So first was a physical property, second's a chemical property. Okay, then we are testing whether a substance will float in water or not. Basically we're testing, hey, what's its density? Density is the ability to float. Okay, well, density is strictly a physical property. So that would be a physical property. Well, the final one talks about potassium and the fact that it can react with just about anything, whether it's the air around it or water. So the reactivity of potassium, Okay, let's think about this. If potassium reacts with something, that's going to mean it's going to change itself. Okay, just like your iron nail reacted with the oxygen in the air to form rust, your potassium is going to react with the air or something, and it's going to form some kind of new object or some kind of new compound. Okay, that means it is a chemical, reactivity is a chemical property. Okay, so that's all I got for you today. That's all the examples I got. Hope this is helpful for you. If you need to, the beauty of a video is you can go back at any point and review stuff. So if you need some more refreshers on chemical physical changes, chemical physical properties, go back and watch this again. Go back and watch the different points, copy down your notes wherever you need to, and look forward to seeing you again. So keep up the good work in the classroom and see you next time.